Session 15, Throughput. Throughput is the amount of outputs a process can generate during a period of time. For example, 10 shares per minute, 100 shares per hour, or 10,000 bottles of water per day. Just like reducing cycle time, increasing throughput is not about pushing the process operators to work harder and faster. It's about making the processes more streamlined and more reliable. Increasing throughput allows sales to increase, reduces overtime and cost, increases on-time performance, and increases profits. The first thing we need to determine concerning process throughput: can process throughput keep up with sales demand for the outputs without overtime? If the answer is yes, then there is no need to increase process throughput. Increasing throughput will only create more unsold inventory. So, you will want to focus your resources on increasing sales by reducing cost, reducing variability, and increasing on-time performance. If the answer is no, process throughput cannot keep up with customer demand, then there is a need to increase process throughput. In class exercise 19, the operators will compare the throughput of the process from earlier exercises to sales demand to determine if throughput for the process needs to be increased. The operators will already know what the throughput is from class exercise 14. Invite someone from sales to present the sales demand data for the process outputs. There may be a need to convert the amount of sales demand for finished product to the sales demand for the process outputs that are at an intermediate stage. For example, let's say the sales numbers are for chairs, but the work cell produces armrest. So the sales numbers would need to be multiplied by 2 to determine the demand for armrest. If throughput is equal to or greater than sales demand, discuss how to increase sales demand by reducing cost, reducing variability, and increasing on-time performance. Someone from sales should participate in the discussion. How to reduce variability and cost will be discussed in later sessions. If throughput is less than sales demand, discuss how the company is impacted. Are there lost sales? Are customers upset about late orders? Is there a need for a lot of overtime? Discuss how the company and the operators will benefit from increasing throughput. There will be higher sales and greater profits, which means more profit sharing for the operators. In sessions 16 through 18, we will discuss how to manage bottlenecks in order to increase throughput. Session 16, Bottleneck Management. The quickest way to increase throughput is usually through bottleneck management. A bottleneck process step is the process step with the lowest throughput when compared to the other process steps within the process. Bottleneck process steps determine the throughput of a process, so knowing how to locate and remove bottlenecks is key to increasing throughput. At any time, one bottleneck process step is restricting the throughput of the operation. Removing bottlenecks is usually the quickest and lowest cost way to increase throughput. The first step in bottleneck management is to locate bottleneck process steps. To locate bottleneck process steps, look for accumulations of in-process inventory. Inventory may pile up and wait in front of a bottleneck process step. Process steps downstream of a bottleneck process step may have to sit idle at times while waiting for the outputs of the bottleneck process step. Bottleneck process steps may require overtime hours of operation to keep up with the other processes. Bottlenecks can be present in any operating department, including the office. If the bottleneck is a document process, there will be a stack of paperwork before the bottleneck process step. For example, an office worker may be a bottleneck and may not always generate production work orders in a timely manner, making production wait and causing customer orders to be late. In the example below, the paint share process step is the bottleneck. Inventory is backed up waiting in front of the bottleneck process step. The downstream dry chairs process step is sometimes idle waiting for chairs. The throughput of the paint chair process step is 10 chairs per hour and determines the throughput of the entire process. In class exercise 20, the operators will review the detailed process flowchart from exercise 3 and locate the process step that is the bottleneck. It will be the process step with the lowest throughput. Answering these questions will help determine which process step is the bottleneck. Does inventory accumulate just before a process step? Do any process steps regularly sit idle waiting to receive inventory from the previous process step? Or do any process steps need to work overtime to keep up with the other process steps? Now that we know how to locate a bottleneck process step, how can we increase the throughput of a bottleneck? Rearranging the process formula that we discussed in session 11 can help us to find ways to increase throughput. The new formula states that throughput equals in-process inventory divided by cycle time. This tells us that reducing the processing time of a bottleneck process step will increase throughput. Reducing process downtime will increase throughput. Reducing setup time will also increase throughput. We can use the same methods already discussed in sessions 13 and 14 to reduce cycle time, setup time, and downtime in order to increase throughput of a bottleneck process step. In class exercise 21, the operators will use the process formula to see how reducing cycle time can increase throughput. Reducing cycle time by 1/2 from 4 hours to 2 hours and keeping in-process inventory the same at 40 chairs will cause throughput to double. If you reduce cycle time by reducing queue time by 1/2, in-process inventory will also be reduced by 1/2 from 40 chairs to 20 chairs, and throughput will remain the same. In other words, reducing processing time, setup time, or downtime will cause throughput to increase. Reducing queue time alone will reduce inventory, but throughput will remain the same. We will discuss this further when we talk about how to reduce in-process inventory. In session 17, we will look at a tool for increasing throughput called a task sheet. Session 17, Task Sheets. To increase the throughput of a bottleneck process step, start by preparing a task sheet that lists all the tasks performed in the process step and shows the task sequence number, a description of the task, the cycle time of the task, and you want to indicate which tasks are value-adding. There's a blank task sheet form in the operator workbook and an Excel copy on the Leader flash drive. You then add up the task cycle times to give the total cycle time for the process step. The process operators should prepare the task sheet since they likely have the greatest working knowledge of the process. To determine the current task cycle times, experienced operators should be able to estimate based on their experience, or time studies of the task can be performed. Precise cycle times are not needed. Estimates of the cycle times should be adequate, and effort should be focused on not trying to nail down the cycle times, but rather on improving the task. To do a time study, have someone observe the task as they are performed, and using a stopwatch, measure the time it takes for each task. The operators should decide whether a time study should be done. They should also choose the observer if they decide to do a time study. Uninvited time studies that are performed by managers or outsiders will harm operator motivation. Using the cycle time reduction methods discussed in sessions 13 and 14, suggest ways to reduce the cycle time of each task. Estimate the new cycle time. Set a target for the new cycle time. If throughput needs to increase by 10%, the cycle time would need to be reduced by 10%. Precise estimates of the new cycle times are not necessary. Focus efforts on implementing the improvements. The actual amount of increased throughput will validate the estimates. As operators gain experience using CHITA, their ability to estimate outcomes will improve. Initially focus on reducing non-value adding tasks. Typically, most tasks are non-value adding, so there is usually more opportunity for reducing the cycle time of non-value adding tasks. For value adding tasks, the initial focus should be on improving quality by reducing variability. We will discuss variability in sessions 19 through 23. When reducing the cycle time of value-adding tasks, there is a risk of affecting the quality of the outputs, which could upset customers and reduce sales. If you see an opportunity to reduce the cycle time of a value-adding task, and there is no risk of hurting quality, sure, go for it. Just remember that keeping your customers happy is critical. In class exercise 22, the operators will prepare a task sheet for the process step bottleneck located in class exercise 20. There is a blank task sheet form in the appendix of the operator workbook. There is an Excel task sheet included on the leader training flash drive. Initially estimate the cycle time for each task based on operator experience. Later you can validate the estimates with time studies of the task if you choose to. In sessions 13 and 14, we discuss several methods for reducing cycle time. The operators will suggest the methods that could be used to reduce the cycle times of the task. Then they will estimate the new cycle time for each task. Task sheets are used to reduce processing time. In session 18, the operators will look at reducing any setup or downtime for the bottleneck process step. Task sheets are used to reduce processing time. In session 18, the operators will look at reducing any setup or downtime for the bottleneck process step. To reduce setup or downtime, prepare a setup and downtime sheet that lists all the setup tasks and reasons for downtime for the process step with the following information: a description of setup or downtime event, the average cycle time for the setup or to bring the process back up from the downtime event, the average frequency of the setup task or downtime event, then calculate the average minutes per day for each setup task and downtime event. There is a blank setup and downtime sheet in the operator workbook and an Excel version on the leader flash drive. Like the task sheets, the process operators should prepare the setup and downtime sheet since they have the greatest working knowledge of the process. To determine the current setup cycle times, operators may be able to estimate based on their experience, or time studies of the task can be performed. You may not have much data on the downtime events since they may not occur in a consistent manner, so focus on the most common downtime events that the operators can recollect. Precise cycle times are not needed. Efforts should be focused on reducing the cycle times. Suggest ways to reduce the cycle time or frequency of each setup task or downtime event. The same methods for reducing cycle time discussed in sessions 13 and 14 can be used to reduce the cycle time of setups and downtime events. Estimate the new cycle time for each setup task or downtime event. Estimate the new frequency for each setup task or downtime event, and then calculate the new minutes per day for each setup task and downtime event. To help determine the downtime events for the setup and downtime sheet, a log of downtime events should be started that lists each downtime event and the time it takes to bring the process back up. Downtime events occur when a process has an unscheduled stop. Some downtime events may reoccur often, like the clogged nozzle in the log shown above. Some downtime events may be one-time events or occasional events like equipment failure. Since downtime events are unscheduled, a downtime event log will help in determining the amount of downtime over periods of time. The log will also help determine the cycle time to resolve the events and bring the process up. A blank downtime event log is included in the appendix, An Excel file is included on the Leader Training flash drive. For class exercise 23, the operators prepare a setup and downtime sheet for the bottleneck process step identified in class exercise 20. As mentioned, there is a blank setup and downtime sheet in the appendix. The operators will initially estimate the cycle time for each setup task or downtime event based on their experience. They can later validate the estimates with time studies of the setup task if they choose to. Using the same methods already discussed, suggest ways to reduce the cycle times of the setup task or downtime events. Estimate the new cycle times and frequencies for each setup task or downtime event. We just discussed in detail 3 tools that are used to increase the throughput of a bottleneck process step: task sheet, setup and downtime sheet, and downtime log. It may appear at this time that a lot of data and effort is needed just to eliminate a bottleneck. But consider that these tools need only to be used on the process steps that have throughput that is less than sales demand. The sheets are prepared by the operators, who should already know most of the data needed to complete the sheets. After preparing the sheets a few times, operators should be able to discern how to increase the throughput of a bottleneck process step without having to prepare the sheets in detail. Increasing sales by increasing throughput can significantly increase profits. Locating and removing bottlenecks is usually the quickest and lowest cost way to increase production capacity. The alternative is to invest a lot of time, effort, and money in additional equipment, inventory, and floor space. As one bottleneck is removed, a different process step will become the new bottleneck. Locate the new bottleneck process step and repeat the discussed steps until the throughput of all the process steps are at least equal to customer sales demand. Coming up next, sessions 19 and 20, variability.